In this video, we're going to be looking at how to make approximations using polynomials. We're going to look at the function sine of x, which is definitely not a polynomial, and see how we can use polynomials to come up with an approximation for this function. Taylor polynomials centered at a point A, would be given by this following expression, where we have the value at A, and then calculate the first derivative at A, multiply that by x minus A since we're centered around A, and we continue on with the second derivative over 2 factorial. And if we look at the nth term of the Taylor polynomial, we would be taking the nth derivative at A over n factorial, and then multiplied by x minus A to the nth power. So we can use this definition here for our example. And in our example, we are looking for, or we're going to find a Taylor polynomial let's find that out to 5 terms. So we'll label that as piece of 5 of x. And for our example here, we'll center about the value x equals 0. And we'll be doing this as mentioned for the function sine of x. So we're going to be looking for a pattern here. Well, we need to know what the function is. The function is sine of x. And we are going to need to calculate derivatives. And so we will calculate the first derivative of sine, which is cosine. And the second derivative. So the derivative of cosine is negative sine. And the third derivative. So the derivative of negative sine is negative cosine. And we can see a pattern developing here. The fourth derivative would lead us back to sine. Now we need to know all of these values at A. So if the function is sine of x, then f of 0, because we're centered at 0, if we plug 0 into sine, we would end up with 0. Likewise, we're going to need to do this for all the terms. The value of the first derivative at 0, so plug 0 into cosine. Cosine of 0 is 1. And at the second derivative, we would have 0 again. The third derivative, so if we plug 0 into the third derivative, cosine of 0 is 1, but we have negative cosine, so that gives us negative 1. And now we've completed our cycle here. Not that all functions are periodic, but sine is periodic. All right, so we're ready to calculate our fifth term polynomial. So f of A, f of 0 is 0. And then we calculate our next term. So our first derivative is 1 times x minus A, or x minus 0, which would give us x. Calculate the third term. We have 0 there. Calculate the next term. So the third derivative will have a negative. We have a negative 1 here. And we'll multiply that by x to the third. over 3 factorial. Our next term will end up with 0 again. And then one more term, cycling back through, we would have a positive 1 and a positive 1 times x to the 5th power over 5 factorial. And we can clean this up just a little bit. So our Taylor polynomial out to the 5th term would be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And if we wanted a better approximation than this, then we could carry it on out to the 7th or the 9th term or beyond. All right, I'll look for any questions you might have on the discussion board.